Find the derivative of g of x equals the cotangent of 1 over the square root of x. G of x here is made up of a trig function, the cotangent of an entire expression, 1 over the square root of x. Since there is a radical involved, I'm going to rewrite that as cotangent of 1 over x to the first power and then square or second root, so x to the 1/2. Now, since we have a constant 1 divided by that x to the 1/2, I can rewrite this using a negative exponent, so this can also be rewritten as cotangent of x to the negative 1/2. Now we're going to take the derivative. Since the trig function is on the outside, we will take the derivative of the trig function first. G prime of x will be the derivative of cotangent, which is negative cosecant squared of the inside left alone, so 1 over the square root of x. But because the inside isn't just an x, the derivative will be more than just a 1. The derivative of the inside, which completes the chain rule, will be best used with this version of it here at the end to follow a power rule. Bring the power down, negative 1/2 x raised to the, and then we will subtract 1 to the power. I'm going to call it negative 2/2. So what we have here is negative cosecant squared of 1 over the square root of x, and then negative 1/2 x raised to the minus 1 minus 2 is a minus 3/2. We can move this out to the front of the expression. There are two negatives. They will multiply to become a positive, and we will have 1/2 x to the negative 3/2 cosecant squared of 1 over the square root of x. Since we have a negative exponent, it can move to the denominator. It'll move down with that 2 that's already in the denominator. So we can also write this as 1 over 2x to the positive 3/2, and then cosecant squared of 1 over the square root of x. The cosecant squared is in the numerator, so one more version that we can write for this is to multiply it with the 1 that's already in the numerator. So cosecant squared 1 over the square root of x divided by 2x to the 3/2. There's our derivative g prime of x.